Well, I certainly echo what was said by both Pat and Bill. I mean, those are exactly areas that are of focus and need urgently, actually. I think the other thing that I would sort of build on what Pat said and say that if you've looked at systems engineering, it's an area that really helps to start taking the big picture and start to organize it in a way about how you start to implement these systems. Most of the industry worldwide is starting to really use systems engineering as a way to try and tackle these problems. And architecture today is one of the biggest areas of need in terms of understanding effectively how to create the urban blueprint, if you will, for what this grid looks like. As we talked about, there's going to be a different configuration to this network as we go forward, particularly in the distribution system. The distribution system was designed for a one-way flow, not unlike the water system. And that's not going to suffice in a world in which we have distributed resources, very pervasive distributed resources, with not just two-way power flow, but n-way power flow. So a completely different architecture or design for that system is going to be required. And then, of course, the overlay of all the protection and control systems and feedback loops and the like. So a lot of opportunity still to be very focused and involved in there. And then again, to build on Pat's point, this convergence of technology, policy, and economics is really at the heart of a lot of debates today about how to move forward with investments, that $1 trillion in the U.S., worldwide, significantly greater. All of that comes, in many cases, in front of regulatory commissions, some legislative involvement on those issues, and trying to really understand how to put forward the best set of programs. There's a big trend right now, you've probably seen in California and other places, where states or countries are requiring deployment roadmaps. Those deployment roadmaps really come at the nexus of this trade-off between the policy, the economics, and the technology, and understanding those other two dimensions in addition to the technology are really helpful in that dialogue.
Okay, so one of the issues that people have been discussing is that information technology is great, and we use it every day, and if it goes oops, computers crash or networks go down, or there's denial of service attacks or something like that. That's a little scarier if it's basically distributing real power, because if you oops on a power, things go boom a little bit more than computers. So I was just wondering,